Hello class, and welcome to our last scientific notation video from this unit. And it is adding and subtracting with scientific notation. And often what some people think is the toughest thing, but we'll try to make it not so tough. So the learning target is I can add and subtract numbers in scientific notation without converting to standard form at any point. We don't want to convert. The whole point of writing things in scientific notation is to make them smaller. So if we had to put them in standard form to do operations on them, it wouldn't be a very useful form. So just like multiplying and dividing, we want to be able to add and subtract without ever going back to them being huge, long numbers. So another way, this blue box here, sorry, I paused it real quick because Miss O interrupted over the announcements. This blue box is just another way to write the same thing, sums and differences, is adding and subtracting. So sums and differences of scientific notation is also what this can be called. And there is a process. So the process here says to, number one, check exponents. They must match. So we'll talk about why they must match. And of course you're going to get examples where they don't match, and we'll explain how you can do those too. But we're going to start off with ones that already match, and then it's really simple if they match. You just add or subtract the coefficients. Remember we said that coefficients often just do what the problem says to do, and that's the case here as well. And then number three, you keep the same exact exponent. So that's the thing that's a little different. Alright, so why do exponents have to match? So off to the side, we'll do a little thought experiment. If I asked you to say, do 3 plus 33. Oh, sorry about that. Paused again. It's one of the benefits of doing videos here at school is announcements. So, and I just wrote that wrong because I was distracted. So I meant to say 3 plus 30. I was already thinking of the answer. And we know that that's 33. But what if I were to write both of these numbers in scientific notation? Which you normally wouldn't, but we still can. 3 is 3 times 10 to the 0 power, because I don't actually want the decimal to move at all. And then 30 is also 3 times 10 to the 1. So I want that decimal to move 1 to the right to make it 30. So I have these two numbers now, and I'm going to add them. So you might be tempted to say, let's say 6 times 10 to the, and then I'm not even sure what you would end up doing adding those two, times 10 to the 1, but that's 60, so that can't work. So we wouldn't be able to use that method. Let's say maybe you decided to make this 6, but then multiply. Well, that's to the 0. 6 times 10 to the 0 it's a little closer, it's 6. But that's not good either. And the reason is, when you add by lining up place value. So if I were to do 30 plus 3, you don't do this. You don't say 60. And that's obvious for anyone who has gotten themselves to 8th grade successfully. You would do 30 plus 3, because the 3 and the 0 are both in the ones. They're both in the ones column. So when you convert it to scientific notation, all that stuff kind of disappears. We don't see this 3 and this 3 as being in having a ones value or a tens value or a hundreds value. Kind of gets lost in that. So we have to rely on the exponent. If the exponents are the same, then these 3's and any of the things that come after the 3, like 3.2, 3, whatever, are going to be nice and lined up. They're in the same exact place value. So what we'd have to do instead is rewrite, let's say, 3 times 10 to the 1, so that it has a 0 instead. And that's what we're going to get into, figuring out how to do all that stuff. But let's first try a couple that already match. So here it is. I blocked off example 2, so you're not distracted by it. We're just going to look at number 1 here. And we have 3.25 times 10 to the 3rd plus 1.47 times 10 to the third. So that's where your eyes should go first, right there. If they match, it's going to be a much easier problem. And you can just go ahead and add up your coefficients. 3.25 plus 1.47. We get 12 there, 7, so 4.72. And then the rule said you just keep it times 10 to the third. All right, let's try another one. We have 5.1 minus 3.8. And notice, again, the exponents already match. 5.1 minus 3.8. Got to do a little trading. We're going to take 10 from here to give it to the 1, making this a 4. So we get 1.3. So we have 1.3 times 10 to the negative, oops, I almost added them together, to the same negative 2. So when they match, you have a much easier time with these. Alright, I brought in a helper for this one. We'll call him Phil. So if the exponents are different, this is where things get tricky. You can't just add right now. I have to do something first. So notice 10 to the negative 3, 10 to the negative 4. That's no good. So you can change either one. I can change the negative 3 to a negative 4 or the negative 4 to a negative 3. But I like to be consistent so that we're not just changing the rules constantly. So I like to take the smaller one, the 10 to the negative 4, and I want it to be 10 to the negative 3. Now remember that hand rule where you hold your left hand out in front of you to make an L? I'll draw my pendant hand again. So there's my left hand holding out in front of me, making that letter L, also indicating that the exponent goes up. So I know if I move, well, I want to say it backwards now, if I make the exponent go up, the decimal has to go left. Before, we were saying if the decimal goes left, the exponent goes up. But now I'm changing the exponent first. So when I rewrite my coefficient, instead of 5.2, I want to move it to the left one to match my exponent going up one. So this is 0.52 times 10 to the negative 3. So we're purposefully rewriting the number so that it's not in proper scientific notation, but so that it matches the other one. So notice now they're the same exponent. I kind of hid. Oh, it looks hideous now. There we go. So let me rewrite that. Times 10 to the negative 3. Okay. So notice they match. Now I can add the coefficients. So 3.8, and now I line up 0.52. See, if I didn't do this, they would have lined up incorrectly. I would have had 5 being in the wrong spot, the 2 being in the wrong spot. So I get 2. This is 0 here. This is 13, and 4. So I get 4.32, and then once again I keep my new times 10 to the negative 3. There it is. All right, let's try it one more time. Switch color. We have 10 to the 7th, 10 to the 6th. No good. We want them to match. So again, I want to take the smaller one and make it match the bigger one. So I'm going to make this 10 to the 7th. I know that's what I want. So what's going to happen to that 7 now that I changed the exponent? Well, as long as I'm always changing the smaller one to make it bigger, I'm always using this rule right here. So because I went up, decimal's got to go left. So this is 0.7 now. And I can add my 2 coefficients. So 1.5 plus 0.7. This gives me 12. 2.2. So my final answer is 2.2 times 10 to the 7th. there it is. Once in a while, you're going to have to fix your answer at the end. Maybe when you add it or subtract it, your coefficient's not between 1 and 10, so you'll have to fix it at the end sometimes. But for now, we're good. We haven't had that happen yet. All right, just a couple more examples, and this time they're word problems. So we have, get rid of that, here we go. Number 5 says, the approximate area of the continent of Australia is 9 times 10 to the 6 kilometers squared. The area of the continent of Antarctica is about 1.37 times 10 to the 7th kilometers squared. The first thing I like to do is just get my bearings straight, figure out which thing is bigger, which number is bigger. And 10 to the 7th, that goes out one more place value than the other one. So it's definitely bigger. It doesn't matter that 9 is bigger than 1.37. This has one more digit in it. Okay, so the first thing it says, find the approximate sum of the land area of the two continents. So sum, that means we're going to be adding the two lands together. So that means, I'm just going to write out my problem here, 9 times 10 to the 6 plus 1.37 times 10 to the 7th. So once I know what I'm being asked to do, I can decide, do these match? No, they don't. So I want to make my smaller one, the 10 to the 6, become a 7. And again, use my left hand. Remember that making the 6 move to a 7 makes the decimal move to the left. So 0.9, and then I'm going to add those together. So off to the side, 1.37 plus 0.9, I can add a 0 there. This is 7, this is 12, I get 2.27. So my final answer is 2.27 times 10 to the 7th kilometers squared. Alright, and then it wants to know what the difference is. This might be more interesting, what the difference between the two continents are. How much more space does Antarctica have as opposed to Australia? The nice thing is when they ask you a follow-up question, we've already done some of the work. So I know that Antarctica is bigger, so I want to put that number first. I'm going to subtract Australia's area. Now, I could write the original again, 9 times 10 to the 6, but I already know that they don't match. So I can just use the one I've already put the work and effort into. And I'm just going to say 0.9 times 10 to the 7th. So now off to the side, I'm doing a subtraction of those two numbers. So this is 7. Got to do some trading. Borrow 10 from there. This is 4. Okay, so 0.47. And this is where I mentioned that this could happen earlier. 0.47 times 10 to the 7th kilometers. But that's not written properly. If I'm going to end my answer with this, I don't want it to be incorrect. So I got to move this over. This is like that class starter where I had you fix them. And we have 4.7 times 10 to the, now I'm holding my hand up in this way, where I'm pointing down, making that R, and that means the exponent goes down. If I moved to the right, the exponent goes down back to a 6. And that makes sense. The difference should be a much smaller number than the sum. That'll be the end of the video. Please don't forget your summary. That'll also help you. If you write a good summary, you'll probably be able to answer the questions at the beginning of the class a little easier. And don't be afraid to write a few questions too. All right, good night.